Hello, friends, and welcome to Machine Learning with Cats, Part 1. My name is Will, and I'm super thrilled to be here with you. Let's see. Let me know in the comments what's the last beverage you've had. For me, it was a pour-over. It was a pour-over of an Ethiopian coffee. I will give myself a formal introduction in a second, but also just want to make sure that we are properly live. Boom. Okay, things updated. It takes apparently a few minutes before I see before all the viewer counts come back. And so for a brief moment, you're like, am I speaking to the cold, dark void of the internet? But hi, my name is Will. I am a software engineer at Google. I'm a coach at Major League Hacking. For the purposes of this stream, I am super into Python and machine learning and cats, because that's what we're doing here today. We're doing Python and machine learning and cats. Today, we're really focusing on the first of those three things. We're focusing on Python because that is where it's going to all begin for us. But water and milk, nice. Oh, good to see, folks. We've got a water drinker. We've got a milk drinker. It is good to see you all. Hello. I will actually, before we get too far down this path, just drop the link to get checked in. So we've got a lot of fun, exciting things this week. We are doing a Kaggle competition. We are predicting how much a cat is worth based on a photo of it. Y'all are going to pick what color glitter I put on my face. It's been a long time. Back in the day, every time I did a stream, it would be like, fill out this form to vote on what color I dye my hair, or like what I tattoo on my arm, or whatever. And we're getting back to basics. So this week, every session you attend, you can cast a vote for what color glitter I put on my face. We have all the glitters right here. Boom. And I will hand out the link to vote for that in the middle of the stream. So if it's like midstream and I have not sent you the feedback form link, let me know and I will drop it. We are also, I guess I'll really introduce the competition and then I'll talk about all the ways that y'all can win swag drops, because there are 5 ways. Good morning, 5:30 a.m. in India. Every time, I tend to have all my streams around 5 p.m. Pacific time, which is, what it is now. And every time I see someone tune in from India, I'm just very impressed because it's early. And I respect you being here. Oh, I'm glad to hear it. Well, I will try to bring the energy. Okay, so I guess let's start by introducing Kaggle. So I mentioned I am a software engineer at Google, and I also do some work with this platform called Kaggle. I do a 20% project. And Kaggle is a platform for machine learning competitions. So the way I describe it to non-tech people is it's like I build an AI and you build an AI and we make them fight. We see who emerges victorious. But if you click through here, boom. Also, always let me know if I'm speaking too fast. Let me know in the comments. And then 2, if the text is too small on my screen, also let me know. Oh, we've got some of the repeat crew. We got Shen Marie. Welcome. Good to see you. Yes, Kaggle. Yeah, all the energy. Polar Void, Alvin, nice to see you as well. Okay, every time I see Alvin on stream, I'm like, damn, do I have something like actually new and interesting? And usually I don't for Alvin in particular, but we just chat. But this time, if you wait until the end, Alvin, we're going to be doing some explainability, and we're going to see. Well, I'll get into it. We'll do explainability. Yeah, I can do a few bumps. Once we get into actually coding, I think that it's more important. But so this is Kaggle. Kaggle is a platform where people can build machine learning algorithms and then pit them against one another. And that's what we're going to be doing. So our competition, because it's Web3 based, and I wanted to be silly, our competition is to predict the price of a CryptoKitty. So CryptoKitties are NFTs, right? I'm not going to explain what an NFT is. I don't know. It's like a crypto trading card, sort of. But if you come to cryptokitties.co, you can see these are what CryptoKitties look like. And on CryptoKitties, you can buy and sell cats, right? So if you click down to here, you can see all these cats. Oh, here's what it's being sold for: 800 ETH. So 800 Ethereum, let's see, 800 ETH in USD is, well, it's not doing the conversion for us. Oh, yeah, it is. That's $1.3 million. Okay, well, it's not actually selling for that amount, but you can see here's a cat that someone is asking for 800 Ethereum for. And so what we're going to try to do in this competition is, based on this image, predict, I guess it's kind of hard to see here, but based on this image, try to predict what price they're asking for. So notice this is not actually predicting how much it's worth. It's just predicting how much someone is asking. So that is where we're going to end up. We're going to end up building an algorithm that can look at a CryptoKitty and say, I think someone is asking for $1.3 million for this CryptoKitty. And like, I want to make it clear up front that this is kind of a silly task, right? There are lots of other ways of going about this that don't involve the images, that just involve data about them. So if you scroll down, you can see they have cattributes, so a different kind of fur and eye shape. But all of these cattributes end up in the CryptoKitty image, right? With the exception of speed, which we'll talk about later. So that is our ultimate goal, and whoever can predict that the best will win, which is very exciting. We'll talk about exactly how to submit. By the end of today, everyone should be able to at least make one submission. Oh, this is a great question. Shinigami, will we be running things on editors or Colab? Yes, so we'll see this in a second. Kaggle has a really nice way to edit code in the Kaggle editor that is basically like a Colab notebook. It's a little bit different, though, in how you set it up. So we'll be doing everything sort of in the same view here. Shemari, I appreciate that. Yeah, drop the link if you want to go look at some CryptoKitties. Yeah, so you do not have to set up, and besides having a working web browser, you don't have to set up anything for this whole track. Now, let's talk about the upside. So by participating in this track, you have the opportunity to win not one, not two, but 5 different opportunities to win swag drops. So once people start submitting, you will see we have a leaderboard here. And the top 2 people at the top of that leaderboard just win. They win swag drops. Beyond that, beyond the 2 top submitters, there are 3 other ways to win a swag drop. And all of these ways, you have to be what's called a Kaggle contributor to win. We'll talk more about that in a second. But one of them, I will just randomly raffle off one of the people that submitted. As long as you make a submission, you'll be in the running for the raffle of someone to get a submission or to get a swag drop. And the other 2 ways are to have a really good discussion. So if you come over to this page, you can see that I just posted a little prompt just saying, welcome to the competition. So you're welcome to ask questions there. But you can also create your own topic. And if there's a particularly good conversation that comes out of that, I want to reward that. So I'll pick the best discussion. And then the best code submission is sort of a separate thing, which we can talk about later. So that's all the swag drops. And then, of course, you will get to pick what color glitter I put on my face. I think that's enough housekeeping for now. So why don't we just jump into it? So if you come over to the code tab right here, you can come down and click Part 1 Python Crash Course. Yes, I will share the link for the Kaggle. Oh, beat me to the punch. Thank you. Always appreciate people dropping links. Ooh, purple or multicolored glitter every time. I love it. Well, so I have, I'll show you in the halfway mark. I have a couple colors down, but if you want to do combos, you are more than welcome to vote for your individual combo that you want. Okay, so now if you're on this page, if you click code, you should see these notebooks, and you should be able to click Part 1 Python Crash Course. So I'll say today we're going to be doing sort of a reintroduction to Python, and then we'll be looking at some of the specific Python tools we'll need for this track. So we'll look at pandas, and we'll actually make a submission to the competition today. So if you just stick around to the end of the stream, you can be entered into the raffle, which is very exciting. So if you click through, you should see this, and this is what's called a Python notebook. So this is a bunch of Python code sort of bundled up in a nice little presentation. And what you can do is if you click edit, I think for you, it will say copy and edit, but for me, it just says edit. It will open up and you can see all of our tools start to appear. You can come and click on this. Oh, you can't really see it. If I scroll, no, we can hide this down here. So this is bigger. So in our notebook, if you've been here before, bear with me for a second. We'll do like the intro to Kaggle notebooks, which are basically Jupyter notebooks. So we have individual cells, and sometimes the cells are just text like this, but sometimes the cells are pieces of code. And if you press the play button on a piece of code, the first time you press a play button, it'll take a second to start up. Oh, this actually started up really fast, but it will run the code for you, and it will spit out what came out of that cell, which is very fun. So that's basically all you need to know about Kaggle notebooks. They're basically Jupyter notebooks, if you are familiar with those as well. So Python. Python is my favorite programming language. I think that Python has gotten really, really popular in the past, 5 years. It's always been popular, but has gotten very popular. And I think for a couple reasons. Python is really, really fast to work in. There are certain sort of safeguards that are removed in Python, but that allows you to be really productive and get things done. It is also one of the most versatile languages. You can write a web server in Python. You can do machine learning in Python. There are ways for you to build web apps in Python. You can, if you really try, you can make a mobile app in Python, sort of. So really, there are a lot of options for you if you learn Python. And specific for us, it is kind of the main language that people use for doing cutting edge machine learning research today, which is, I guess, one of the particular reasons that we are here learning it. So the most basic thing that we can do in Python is to tell our computer to remember a little bit of information. And we do this by creating a variable. So a variable is just a label that we give Python to attach to a piece of data. So here, if I say my integer equals 6, I'm telling Python, hey, remember this number 6 and attach the label my integer to it. So if I ever ask you for my integer, then tell me it's stored as 6. That is an integer, of course, that is just a number with no fractional part. We have floating point numbers, which you can see I did 16.5, so it remembers a fractional part. Let's see, you might not be able to open and edit. Yes, so you will need a Kaggle account for this. It is, I will say, it is a pretty good deal in terms of they give you so much free compute. You can get actually, I think, 30 hours of GPU time every week, which is kind of absurd. There are sometimes conversations inside Google about like, wait, why are we just like giving away all this GPU time? But it works as part of this, sort of machine learning ecosystem. But yes, if you do not have a Kaggle account, you will not be able to open this up, but you should be able to make a Kaggle account very quickly. Cool. So we can tell Python to remember an integer, we can tell Python to remember a floating point number, and we can tell Python to remember a string, which is just a string of characters. That's sort of our fancy programmer word for text, right? We can tell it to remember text. And finally, we can tell it to remember a Boolean. And a Boolean is just true or false. That's all a Boolean is. It's, again, a fancy computer science word for true or false. So when we click run on this cell, we can see 6, 16.5, hello, and true. It remembered all of our data for us. Now, I want to pause for a second. 1, check in, see if everyone's doing okay. And then 2, actually, I want to do a chat poll. I'm curious how good everybody is at Python. So give me a 0 in the chat if you have never heard of Python before today. Give me a 1 in the chat if you've like maybe interacted with Python but are not very confident. Give me a 2 in the chat if you are feeling good about Python, like, hey, I'm not a pro, but like I can use Python. And then give me a 3 if you're like, I am a Python god. So 0 is I've never heard of Python. 1 is I know it, but I'm not really confident. 2 is I'm confident. 3 is like I should be running this stream. And I will say for myself, I usually give myself a 2 on these polls, but because I phrased it as I should be running the stream, I'll give myself a 3 because I literally am running the stream. Okay, cool. So we have, I will say this is, and if you're a 0 or 1, like please let us know, because otherwise, if we've got a lot of 2s and 3s, I will move a little bit faster. Because right now I don't see any 0s or 1s. So if you're a 0 or 1, let me know, and like I will absolutely like today is the day to just walk through relearning Python. But I'll give it another second. But if we just have a lot of folks that are confident, then okay, we got a 1.5. Why am I red? I don't know what that means. Also, fun fact, I'm colorblind. So if you're asking a color question, I cannot help you. Okay, cool. So we have a 1.5. So I'm not just going to skip over things, but it sounds like given that everybody has at least some familiarity with Python, I will not spend too much time just like telling y'all about variables, right? Maybe we'll speed run the first little bit, and then we'll get to spend some more time sort of digging into some more interesting things. So we know about variables. We know that we can add, subtract, multiply, and divide integers, right? 2 of our bonus ones, of course, we can raise something to the power of something else. Let's see. A to the power of b here is 29 to the power of 5. And then we can also do integer division. So a divided by b says divide 29 by 5, but throw away any remainder. So hopefully we can look at these and we can walk through them. Yep, 29 plus 5 is 34. 29 minus 5 is 24. You can walk through these. These all look right. But an interesting thing to note is that when we said a divided by b, even though both of the things that went in were integers, we got a float out. Obviously, a to the power of b is a really, really big number. But then when we integer divide, it's the same thing as when we regular divided, but it just threw away the decimal part. Shemarie, just wanted to check in. If I commented on someone's appearance, let me know, because I did not intend to. But if this was somebody else, yeah, let's just keep it all. Let's keep it all via the code of conduct. Oh, that's actually a thing to throw out, is if you participate in this competition, you are agreeing to abide by the MLH code of conduct. So that's something to be aware of. Right on. So you might say, okay, I know we can do these things with integers, and that sometimes we'll get floats, but how do I know what the type of something is? We have a very nice tool called the type function. So if you run this, you will see what the type of the variable you put in is. So the type of my floating point number, and it said float. Oh, why am I flushed? Oh, yeah, for one, it is quite warm in here. It is summer in Seattle, and so I'm getting a little toasty. So we know the floating point number is a float, and that is, I suppose, good to know. This is actually one of those things. I said that Python removes some of the safeguards, and one of those safeguards is strong typing. So in a language with strong typing, like a thing is one type, and like at compile time, you will know if you're doing something that you're not supposed to do, right? Like one function accepts one type of thing, and like you can't muck around. In Python, they give you the option to sort of generalize and say, well, hey, if I have a notion of adding that works for numbers, why won't my notion of adding work for strings? And like sometimes that's okay, but sometimes that's not what you want at all, right? And we can maybe look at this when we get into functions. That could be like a fun thing to given that we have a little bit of a higher level of Python right now to get into. Of course, we can group things in parentheses. So these two operations, if you order them differently, then you'll get different results. I am actually a big pro over parenthesize. There are cases where just based on sort of the default Python order of operations, you will get the right answer. But as the Zen of Python says, explicit is better than implicit. And so using parentheses to make it very clear the order in which you want things to happen, I usually am a fan of. We can, of course, add strings together. That's called concatenation, which is one of our $12 computer science words. So I have a variable called my name. I add it to the strings hello and exclamation point, and we get a greeting. Hello, Will. But usually, if you want to do something like you have a string and you want to put another string inside of it, you want to use what's called a format string. So we do this by putting an F at the beginning of our string, and then these little curly braces with the name of the variable that we want to interpolate. Interpolate, another great CS word. I should have like a counter that's like every time there's a CS jargon word. We had concatenate, we had interpolate. These are all delightful words. So you can see here, we get this sort of for free. We don't have to explicitly say, sort of like add these things together. We're just telling it, hey, take the drink name and put it in these curly braces. Booleans, our last sort of fundamental data type. They're always either true or false. And you can do things like Boolean logic. So it is sunny in Seattle. Technically right now, it is sunny in Seattle. It's always sunny in Seattle. I think that's the name. Ooh, yes. Great. Iterate. You can make a song. Yeah, no, iterate's a good one as well. I love the word iterate. Can you explain interpolate? Yes, absolutely. I can explain interpolate. So broadly, I mean, interpolating something is just putting something inside something else. And so in this case, in this string, we are interpolating the string drink name. So we're saying this thing that exists outside of our string, we're going to put it inside our string. I'm actually kind of curious. Interpolate definition. Insert into something else. So there you go. To interpolate just means to insert into something else. But because we're nerdy computer scientists, we couldn't just say that, you know? But thank you for the question. How long do you have to stay here to check in? I actually have no clue. I mean, like, I think the check-in link works like regardless of if you ever open Twitch. I mean, like, you shouldn't do that. That would be dishonest. I will say it'll be about halfway that I'll drop the feedback form, and that is where you can vote for what color glitter I put on my face. Radical. So Boolean logic. You can have a variable that's true. You can have a variable that's false, swapped. It technically is kind of sunny in Seattle right now. You can see the sun here, but that's not really what we want to. That's not really what we want to demonstrate. So pretend like it's not sunny in Seattle. It's usually this code block works well. Let's see. We can use and, or, and not to play with our Booleans. So sunny in Seattle and I want coffee. That'll be false, right? Because both of these things aren't true. Sunny in Seattle or I want coffee. This, of course, is true because at least one of them is true. You can also use not. So if we're saying sunny in Seattle is false, then not sunny in Seattle is true. And a true thing anded with a true thing is true as well. So we can predict that we will see false, true, true. Boom, false, true, true. Logic still works. Why would you want to do that to yourself? I don't care. I mean, like, I'm here to have a good time. Like, don't be dishonest. That's, you know, that's shitty. But yeah, I'm not like, if you don't want to be here, don't be here, you know? Osama says, nice, I am just finished Python in Kaggle. Nice. Yeah, so this is actually a great thing to call out. If you want to follow at the same speed that I'm going, you're welcome to. Also, you can open this up and go at your own speed. If that's faster or slower, you know, you do you. Oh, I will say, well, yeah, I'll drop the form sort of halfway through. But again, if I'm going too fast or if there's something that we're not explaining, like, would love just to get a question about it in chat if you have one. So we've dealt with data types that are sort of simple and only have one thing in them, right? Strings are kind of a little bit different because you can have many characters in a string, but sometimes we want to deal with lots of things at once. EHUS says, what are we covering? So in this stream, we're doing our intro to Python or re-intro to Python, topped off with looking at pandas and a few other libraries we're going to use this week. And then we'll end with learning how to submit to the competition. That's what we're covering. Good question. So sometimes we want to do Python, but for lots of things at once, right? And to do that in Python, the main tools that we have are strings and dictionaries and loops that we'll touch on right after this. So to make a list of things, I think I said strings, lists and dictionaries and loops. So to make a list of something, I can just put the individual items, separate them by commas, and then put them inside square brackets, which, given that most people are familiar most people who are familiar with Python, this is not shocking, but we can create a variable with a list in it, and then we can add things to the end. So if we run this, you see we have Nashville, Boston, Seattle, San Francisco, and we have a list of cities. In order to see what's inside the cities, you can use the index of that city. Now, an interesting factoid that, of course, if you're familiar with Python, you already know, this is a little small, is that we start counting at 0. So 0 will be Nashville. 2, if we start counting at 0, will be 0, 1, 2. So 2 should be Seattle. And then 3 will be, of course, 0, 1, 2, 3. Boom. Seattle, Nashville, Seattle, San Francisco. That lines up with our expectations. So now we have a list. This is something that someone asked last time that we covered was tuples. So lists, a nice thing about lists is that you can change them, right? So for example, if my list is 1, 2, 3, I can say at the 2 index, now put a 7. And if I run that, we'll get 1, 2, 7. But if I make a tuple, so a tuple is like a list, but we create it using parentheses. And it is like a list, except for the fact that it cannot be modified after it is created. So if we try to do the same thing we did for our list, but I say my tuple, second index is equal to 7. Or sorry, not my list, my tuple. We get an error. Now, tuples, actually, like pop quiz, what, why would you want a tuple to not be mutable? Oh, mutable, that's another good word. So mutable just means you can change something, and immutable means you can't change it. Let's add those. Mutable can be changed. Immutable cannot be changed. Does anyone know why we would want something that's like a list but you can't change? Okay, this is a good like in general, the idea of having constants in computer science is like, yeah, it could be a good reality check to compare something against. There's also a very specific reason that I'll bring up later when we get to dictionaries. Does Kaggle is enough for ML? Do I have to follow the Kaggle roadmap just like it is? Apologies, I'm not 100% sure what you're asking here. I think Kaggle has lots of really great resources for learning about machine learning. And for our track, like all that we do is going to be on Kaggle, if that answers your question. Okay, cool. And of course, the type of my tuple is tuple. But so a tuple is just like a list, except it is not mutable. So now dictionaries. Dictionaries is very fun. Dictionaries are very fun. So sometimes we just have a list of things, but sometimes we have a relationship between two kinds of values. So for example, every city has a population value. And maybe I want to store both cities and their populations. And you could say, hey, have one list of cities and one list of populations. But then we get into this weird thing about ordering. And if I just want to know the population of a city, it's not that easy to do with two lists. So dictionaries give us the ability to create this kind of relationship between a key and a value. So if you're familiar with a dictionary in real life, it is kind of the same. Our key is like the word, and then our value is the definition. So here for city populations, we can say Nashville, the population is that. Boston, the population is 684,000. And we can look at our dictionary. Now, to get a specific value, we can index into it with the key that we originally set up. So instead of saying 0 or 1 here, we can just say city populations of Nashville, and we get that number that we put in there. Let's see, you might want something to be mutable because it's dynamic and you want one to be immutable to reference it later. Yes, these are generally, I think these are broad reasons why it's good to have things that can't be constant, and like they're not incorrect by any means. Yeah, so technically if it's immutable, like it can never be changed. Not like it only changes rarely, but like it can never change. And one of the big reasons that we actually want to use that we want some things to be immutable is because keys in dictionaries must be immutable. We can get into given that there's more familiarity with Python, we can get into the actual reason why. That could actually be a fun little sidetrack thing. In fact, let's actually maybe let's finish our intro to dictionaries, and then we can get a little bit nerdier. So city populations, we can add new values to our dictionary. In order to update a dictionary, you basically pretend like the key already exists and you put some data in it. So in this scenario, we say Seattle has a population of 724,000, and that goes in there. And San Francisco has a population of 815,000. And there you go. We've updated it. Two other really useful tools here are to use the dot keys and the dot values. So here we say city population dot keys, and we get an iterable, that fancy word, iterable, of all of our keys. And then for dot values, we get an iterable of all of our values. Any questions on that before I get into this little nerdy moment about how dictionaries work and why we want immutable things? All right, I'm gonna create a little side thing here. We'll say random nerdy tangent about how dictionaries work. Boom. So fun fact. So I interview a lot of people for jobs at Google, and there is this sort of joke that like for these technical interview questions, like 9 out of 10 times, the answer is a hash map. And a hash map is basically a Python dictionary. And there are a lot of sort of special things about how hash maps work that make them super useful in a lot of scenarios, especially technical interview questions. So for just a motivating example, let's say what do we want to call this? Ooh, okay, let's say we have a group assignment and we have, or group project, and we have group project grades. We have group project grades, and we want to have our keys be a list of students, and then the value will be the grade they all received together. So what if we called group 1, let's see, who's on stream? We can say Shemarie, we can say Ehus41, and we can say Palak. Boom. This is group 1. And what if I wanted to say group 1 gets a 100%? Well, if I run this, I will get an error. And it says unhashable type list. Now, for our purposes, hashable here for right now, hashable is kind of the same thing as mutable. If you're mutable, you're not hashable. But if you're immutable, you are hashable. So like being mutable and being hashable, you kind of can only pick one. Now, we have an immutable data type that is like this. It's called a tuple, and we can change it by just putting our parentheses here. And if we do this, it'll actually work. And in fact, we can then just see, okay, our value is these three, our key are these 3 usernames, and then our value is 100. Yeah, hash map is the universal answer. Yeah, so JSON objects are there are a lot of different ideas here. There's like a JSON serialization, and then there's like in JSON or in JavaScript the notion of objects, and there are some distinctions, but objects in JavaScript are essentially dictionaries in Python in most ways that matter. And under the hood, they are implemented as a sort of modified hash map. So yes, basically all the things that I will say will be basically true. So why is this true? Why do we need something that is immutable as a key in a dictionary? Well, to prove this point, because we've got nothing but time, and most people here are already pretty familiar with Python, what if we just implemented our own dictionary in Python? So this is like data structures and algorithms, like end of semester in college, right? So if you take data structures and algorithms, this is maybe something that you've been exposed to before. So we have a function in Python called hash, and you can put literally anything into hash and get an integer. So if we put 1 into hash, we get 1. Interesting. But what if we put hello into hash? We get some random number. Now, a thing that's very, very helpful about this is that it can turn anything into an index. So say we have some memory, and say we have 10 empty spots of memory. And we have indices, right? We know this is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 10 sort of spots in general. And I want to put some data in memory, and I want to be able to get access to that data instantly. I don't want to have to go and look through all of my items. I want to know exactly where it is. So one option is to say, let's hash our value. So let's say I have a few things I want to put in there. Let's say I want to put apple, banana, and citron. So these are the 3 pieces of data that I want to put in there. And what I will do is I will say, okay, I'm going to hash apple, and I get some big number, and then I will mod that by the size of my memory. What this does is it turns the hash of apple into a number that's inside my memory space. And so once I do that, once I get the hash of apple and I turn it into an index, I can say inside memory, we'll call this apple index. And we can say memory at apple index is equal to apple. Now, if we look at our memory, we can see we have nothing, and then we have apple right there. So this is like step 1, insert apple. Now step 2, insert banana. And let's just make a variable called banana equal to banana. Oh, thing we didn't really talk about, in Python, you can use single quotes or double quotes. And in general, the thing they suggest is just be consistent. And I was not being consistent there. Cool. So if we want to insert banana, we can do this same thing where we calculate a banana index, which we take the hash of banana, and we mod it by the size of memory. And so our banana index, let's see what our banana index is. It's 4. And so we can say inside memory at banana index, insert banana. So now we can see our memory is filling up a little bit. We have apple and banana in no particular order. It's just based on our hash, right? And then finally, for step 3, we can insert citron. So we can say citron equals citron. Do the same thing where we hash citron and turn that into citron index, which, oh no, okay. Because this is, I don't want to get too deep into hash tables, and so I'm going to pick a different thing. What's the different, oh, cherry. Cherry is a much more normal fruit. We can talk about how to handle collisions. What just happened is 2 hash values collided. But it's easier just to show this example if it's not that. So let's see. Okay, great. So yeah, the hash of cherry is 0. And so we can say at cherry index in memory, store cherry. Cool. So we now have a few things in memory. And now I want to check to see if things are there, right? Like I want to see, is cherry in our dictionary, say. Which really, if this was a dictionary, we'd have 2 values here. We'd have cherry and then and then some data about cherries. But it works essentially the same way. And so I want to see, is cherry in our memory space? And if this was just a list, then I would have to go through all of memory and check, is cherry here? Is cherry there? Is cherry there? And this is what we call an O of n running time complexity. So O of n means you have to look at all of your data to do what you want to do. And sometimes you can get lucky, right? Like sometimes cherry is the first thing in your list and it's fine. But on average, you will have to look at, like, or in the worst case scenario, you will have to look at all of your data to do what you want to do. But we don't have to do that because we have a hash table. So we can say, okay, is cherry in memory? Well, we can just recalculate our cherry index by saying hash cherry. Hash cherry mod the length of our memory. And then we can just see what's inside memory at that index. And we see cherry is still there. So now why does this mean that keys have to be immutable? Well, imagine if cherry, our key here, was not immutable, and I actually updated cherry, and I said cherry is actually equal to tangerine. Now, if we run this, we get none. So if I actually print this out, you'll see the value is none, and nothing's there because we updated the value of our key. And this is sort of the reason that if you're going to use something as a key, it needs to be immutable. Now, a tuple can work, a string can work because strings are notably not immutable. Strings are not mutable. Let's see. Oh, we've got some comments. Sorry, I was in the zone. I was just vibing to, I love data structures and algorithms. So I was just vibing. So let's see. Apple will always be 5. Yes, you understand that totally correctly. You didn't answer my question that I do have to learn step by step as Kaggle courses, as it is only for ML. I'm a full stack learner. Yeah, I mean, so if you are, so I will say that Kaggle does have educational resources. I think that Kaggle's sort of ethos is to learn by doing. So the main thing on Kaggle is competitions. And so like this competition, every competition gives you a challenge and then usually a lot of tools to learn how to deal with that challenge. And I think that it is really, really good if you want to learn about data science and machine learning. It's not like the purpose of Kaggle is not full stack engineering. It is purely a data science and machine learning platform. I would say if you are coming from a full stack background, then Kaggle should be really useful to you. I know they have like over here the little educational icon. I have not done a lot of Kaggle courses. And so I would not be able to recommend them. Actually, I've done 1 or 2, and I think they're nice and often well done. But really, much of what Kaggle does is these competitions. But I think they are really a great way to learn. But I don't think there's any sort of specific order you have to go through. I think that you can sort of choose your own adventure. Collisions happen. Yep. Hash is created based on the data we provide. Yes. So a hash function just basically takes whatever data you give it, it grinds it up in some way, and then gives you a number back. It decides on the size. Yes. No. The understanding here is correct. The length of the data makes the hash longer. This is not actually true. I don't believe. So for example, if we hash, let's see, short data, we'll have the letter A, and then long data, we'll have A times 1,000. And let's just make sure that long data is what we think. Yeah, so this is long data and short data. And if we hash short data, we get that kind of number. And if we hash long data, we get sort of a similar size of number. Now, when we hashed 1, we got 1 because Python's hashing algorithm nicely for, I think, particularly for small integers, will preserve the integer. So if I hash 1, I'll get 1. If I hash 2, I'll get 2. I think that might actually be true for all integers that are like a normal, quote unquote, normal integer. Now I'm kind of curious. If I hash 1, 2, 3, 4, 5, there you go. I get 1, 2, 3, 4, 5. So that's kind of cool. Yeah, this is a great thing to throw out. So when you are doing a technical interview, particularly for a sort of back end or full stack role, the technical interview will be really grounded in running time complexity. I will say for machine learning sort of engineers and scientists, interviews sometimes will still have sort of basic data structures and algorithms content. A lot of times they will care about performance, but in a different way. They will like being able to scale things efficiently becomes really important. But yeah, it's less about sort of normal running time complexity. And yeah, I would say on average that like running time complexity will come up less for machine learning engineers, and model accuracy is more important. So yeah, we had this question, every data will generate a different hash. So if you think about it, there's a set number of numbers and you can hash anything. And so there is this possibility of collisions, right? You could hash two different things and it's possible that you could get the same number. And this problem becomes even worse when you start trying to mod your number, your large number into a smaller space. So here because we can't, the hash of this is 1, 2, 3, 4, 5, but we don't have 12,000 spots in memory, at least for our toy example. So we have to turn this number into something in between 0 and 10. And so if we take that number and we mod by 10, then we get 5. And in that space, it's actually very easy to get the same number twice. So good hash tables will have a good way of handling when this happens. It's called a collision. And yeah, it'll deal with sort of figuring out what to do in that scenario. There are lots of different solutions that I think probably are beyond the scope here. Yeah, but great question. I think it's the logical next question to ask. Okay, wow, this is great. We've done like half of a CS undergrad at this point. So let's move along to ifs and loops. So sometimes you want to only run a piece of code if something is true. So for example, I say pineapple belongs on pizza. This is of course true. Pineapple on pizza is delicious. And if it is true, then I want to print out, I like pineapple on pizza and I don't care who knows. We can run that, and it is, of course, true, so it prints out. But if in a different world, pineapple on pizza wasn't the thing, and it was false, this would not run, right? Basic if statement. One thing that if you're coming from a different programming language, blocks of code are created by indentations in Python. So like in another language, you might have something like this with curly braces. That's not what we do in Python. We just say, throw a colon up here, and then everything that's indented is part of that special block. So I could do other stuff in here. Like I could assign a variable and I can print it out. Oh, lowercase x. And here you would get that additional stuff. If statements, you can also use comparisons in if statements. So a comparison will go from two separate values to a Boolean. So this comparison right here becomes a Boolean. And then if that Boolean is true, then it executes. So if we are 30, then you can get a driver's license in the US, but you are not feeling 22. If we were exactly 22, both of these things would happen. An interesting thing to note, this is true in most programming languages, but because we use the equal sign for the assignment operator, right? Remember earlier, this is like telling Python, put this data inside of X. In order to check for equality, we have to use double equals. So this is actually checking to see if there is an equality relationship, and that becomes true or false. Cool. We can use loops to do something multiple times. So say I wanted to automate my job, and I wanted to say hello to hackers on stream with Python. I could create a list of all of the hackers. So let's see who's in chat. Palak. Oh. Srivanik, Shinigami, and Ehus 41. So I have a list. Importantly, it doesn't have to be a list. It just has to be something that I can iterate through. So this is that fancy word, an iterable. Anything that has lots of parts that you can iterate through is an iterable. So strings are iterables because they have lots of characters. Lists are iterables because they have lots of elements. And then dictionaries are iterables because they have lots of keys. These are all sort of things that you can do a loop over. So we can say for hacker in hackers. We can, let's say, make the hacker's username uppercase and put it in a variable called loud hacker, and then we can print that out. So let's run this. Welcome to the stream, Palak. Welcome to the stream, Shrivanik. Welcome to the stream, Shinigami. Welcome to the stream, Ehis41. Yeah, hey, if you want to be called out, then just drop a chat and I'll add you to the list. You'll get called out. The Pradiptox. I can spell. The Pradiptox. And Shemari. And I appreciate you saying that you're still here and don't even list, but we're putting you on the list. You're here. And Sarvesh. I appreciate it. It's good to know. I think Alvin had to drop. So it's whenever some of the repeat hackers come, it's always nice to know we're hanging out. Micah? Boom. So I'm saying hello to all of you. Good deal. Something that hadn't come up yet is that you can use plus equals in order to add something back to the variable. So in this scenario, plus equals just adds 1 to my num. Also, when we're done running through our loop, I can talk. The last hacker will still be in hacker. So this actually technically doesn't get removed when the loop ends, which is a little bit weird. We can also use loops on dictionaries. So I have a dictionary of ages, my age, my boyfriend Richard's age, and the age of Benjamin Franklin. And we could say, what if everybody gets a birthday? So we could iterate through our dictionary of ages, and we'll get all of the names. So when you iterate through a dictionary, you get just the keys and not the values. And then we can say, okay, inside ages, for each key, let's add 1 to the age. So you can see we printed off all of our keys, Will, Richard, Benjamin Franklin, and then we have 28, 25, and 319. Yeah, old Ben is old. Is scope non-existent in Python? This is a great question, and the answer is kind of. Like Python plays fast and loose with scope in many ways. Functions are still properly scoped, but you do get some scope leakage from loops. This is something actually that I want to get back, or I want to dig in more to have like more philosophical opinions about scoping in Python. Yeah, there certainly is a concept of scope. Can we loop through the values? Oh, great question. We can. We just can't do it for free. So one thing that we could do. So we'll say question. Can we loop through values? So we have a couple of ways that we can do this. One is we could just say for key in ages, and then you can just get the values just by saying, ages key, right? So that gets the values. You can also say ages dot values, and there you can just get it directly. So sort of same way of accomplishing it. And then the final way that I actually find to be very useful is you can iterate through a dictionary dot items. And this gives you both the key and the value. So you can print key value. And so here we get both the key and the value together. Let's see. I'm always confused with global keyword. So I will say in general, like global variables are a bad idea. I would just generically recommend against having global variables. But there are some weird, like you can get into with some multiprocessing things. There can be scenarios where you want them, but I would say global variables outside the scope of this, usually, especially for machine learning-y things, don't define global variable, or don't, like, in a sense in which you're doing scoped things, don't define global variables. Cool. Yeah, so this is a notebook. There is, I mean, there is a full Python interpreter running under there. The thing that is different is just that it will pause in between cells, right? But yeah, there are, like, in terms of me saying don't declare global variables, and it's like, well, hey, Will, isn't ages a global variable? And it's like, yes, it is, but yeah, we're just teaching you stuff, you know, or we're just reviewing Python, not writing hard hitting production ready code. Okay, cool. Functions. So yeah, actually, great moment to get into scoping. So a function is like a little package, a packaged up bit of code that you can reuse multiple times. So this, of course, is a little bit silly because we can add like without a function, but you could say, given two numbers, foo and bar, add them together. And so if you call my adding function on 2 and 6, you, of course, get 8. This is one of those things that it's like, oh yeah, Python lets you just do whatever you want to do. So we could have two strings. We could have hello world, and it will add those together because it has a notion of adding. Now I'm wondering, like, are there other weird variables that have a good notion of adding? I mean, of course, well, what if we said true and false? We get 1. Which is another interesting, when you add booleans together, ones or trues gets treated as ones and falses get treated as zeros, which is interesting. So it lets you do things that you might not necessarily know how to do. But importantly here, so we returned my sum, and so at some point my sum existed in the world as 1. But if we check my sum, not defined, because it was only defined in the scope of our function, and Python functions are scoped. There you go. Asked and answered. And yeah, we'll stay away from global variables. Okay, well, we're about at an hour here, so I think I will take that moment to drop the feedback form. Let's see if this works for everybody. So you should see a form like this. You do have to put your email in there, just because I want to limit people from trying to hack it and adding, like a gajillion votes for things. I'm always interested in if the speed of the session was good for you. I think this is one of the first times that most people who have joined the stream have been decently comfortable with Python. So I'm very curious to hear if this felt slow to you, or if it still felt like we were talking about interesting things. And of course, how enjoyable it was. And okay, so I only give you 4 options, but really I wanted to let you add your own as well. So let's add to here, add other, boom. Well, no, I just want to save it. Cool. Let's go back. And now hopefully, yeah, you should be able to type in anything. So what we'll do is, for this stream only, you can type in your own item. And then next stream we'll vote and we'll do a round robin where whatever option gets the fewest votes gets eliminated. So yeah, and I think we already have we already have 6 responses. That's great. And yeah, let me know if you have any other questions or if there's anything that you wanted to let me know about the stream. Cool. So functions are scoped. That's great to know. Recursion. Okay, yeah, this is great because we're doing Python Crash Course Advanced. Let's talk about recursion. So the Fibonacci sequence is the series defined by starting with 1, 1, or you can say starting with 0, 1. And then for every step, you add the 2 previous numbers to get your next number. So 1 plus 1 is equal to 2. Then 1 plus 2 is equal to 3. Then 2 plus 3 is equal to 5. Then 3 plus 5 is equal to 8. Then 5 plus 8 is equal to 13, and so on and so forth. It's actually really cool. It shows up examples of Fibonacci sequence in nature. Boom. So I won't go as far to say it's obvious how this is the Fibonacci sequence, but there are a million different ways where you can show that this flower is exhibiting the Fibonacci sequence. Flower petals, tree branches, nautiluses, faces. There you go. And so what if we want to write a function that given a number, it returns to us the Fibonacci number at that index? So for example, if we say index, and then down here we say fib number, the 0th fib number would be 1. The first fib number would be 1. The second would be 2. The third would be 3. The fourth would be 5. The fifth would be 8. And then the sixth would be 13. If that drives with your little human brains. Oh, what? Wait, what movie with Tom Hanks on the Fibonacci sequence? I love Tom Hanks. Yeah, Fibonacci sequence showing up in Flowers. So, so there are a lot of ways you could write this. There is a way with that you can write the Fibonacci sequence with a for loop, but you can also write it recursively. So recursive, another one of those $10 computer science words. We've got immutable, interpolate, concatenate, recursive, iterable. I think we're up to 5. But it is simply when you call a function from inside itself. And whenever you do recursion, the sort of like rule number 1 of recursion is that you must always have a base case. There must be some circumstance under which you do not call the function from itself. And for us, that's just we know that the first 2 numbers of the Fibonacci sequence are 1, right? So if n equals 1, or n equals 0, we're just going to return 1. And that's we just get that for free. That's baked in. Otherwise, the way to arrive at the Fibonacci number of an index is to first find out what the Fibonacci number before it was, and then figure out what the Fibonacci number 2 before it was, right? So like if I want to know the index or the 6th Fibonacci number, then really what I want to know is what are the 4th and the 5th. And if I know the 4th and 5th are 5 and 8, then I can add those together to get the 6th. If your brain is like exploding right now, don't worry about it. Recursion is funky, but we're only touching on it because this is, sort of intro to Python advanced. So you can see that unless it's 1 or 0, we're just going to go and get those 2 previous numbers and add them together and return them. So we can run this and we can say Fibonacci of 4, we get 5. And we can go through and we can see, yes, the 4th Fibonacci number is in fact 5. Oh, Da Vinci Code. Okay, this is actually, I have read Da Vinci Code. I've never actually seen the movie, and I really want to. It should be on the list. Now you can see when we run it on 20, still pretty fast. What if we run it on 100? Okay, so you can see once we hit 100, it starts to slow down. And this is because oftentimes, there are times where a recursive function is like the most elegant solution to a problem. But for something like this, recursive functions can blow up really quickly. Because one way of thinking about it is for every step of our function, we're calling 2 new functions. So like on the first step, we call it twice. But then on the second step, we call it 4 times. And then on the third step, we call it 8 times. And this just results in more and more function calls that all take memory and time. So we hit a point at which this was no longer like a really viable solution. But recursive calls are still kind of fun. Okay, any questions about dictionaries or hash maps or scoping or recursion? We good? Yeah, this is okay. If you've ever been on Stack Overflow, this is what it's talking about. Every time you do a call to a function, that function call gets placed on the stack. And if you make too many recursive function calls, you will fill up the stack and you will get Stack Overflow. And that is why people are nasty online to each other. Okay, if we have no other questions, then maybe we'll do libraries and pandas. Hey, you're going to learn more about hashing in Python. I will say, okay, I don't read a lot of source code, but I did read the implementation of dictionaries in Python. It's actually kind of a cool piece of code to look at. I am a fan. So in the same way that functions are little bits of code that we can reuse, libraries are sort of larger bits of code that we can borrow from other people. So the way that we import a library in Python is just by saying import and then the name of the library. So one common library people will import is called random, and it does random number generation for us. Then in order to use things from inside that library, we put a dot and the name of the thing we want to use. Now, a lot of libraries are a little bit, they can get a little bit confusing because a lot of times a thing inside the library has the same name as the library. So here, the library name is random, and then the thing inside the library we're using is also called random. That can be a little bit confusing at the beginning, but you get used to it. So we get a random number between 0 and 1, and that can be useful for all sorts of things. We can also, if there's a library that we don't have in our Kaggle notebook, we can install it. We just say pip install numpy, which numpy already was installed, but it can still be nice to show this off. So it says requirement already satisfied. But now that we have installed numpy, we can use a library. Why is there a bang before pip? This is a great question. So everything in the Kaggle notebook is Python unless you tell it otherwise. So starting a line with an exclamation point basically asks the Kaggle notebook to run this command as if it were a bash command. And this basically is a bash command. So this runs in the background in a bash process, pip install numpy. And so the starting with a bang just says, please run this as if it was bash, as if it were bash. So if you want to know all the stuff that you can do in a library, Python gives you this tool called dir. And I believe the dir is short for directive. I don't know. But it will give you a long list of all the things inside of that library. Now, to me, sometimes if you kind of know what you're looking for, it can be helpful. But for me, usually this is just kind of scary. And so usually if there's a library you want to learn more about, you can just go and find the documentation, right? Python random documentation. Boom. And here you have the documentation. And it can also be a bit dense. It's written for computer scientists, you know. But usually if you just look for random dot, say random, you can get a little explanation of what this is doing. So return the next random floating point number in the range 0 to 1. Nice. But dir also works. Will that error make the program not work? Oh, this right here. That is a great question. So the short answer is no. This will run, and because it's just a warning, it does not actually break anything. And yeah, this is sort of a pretty graceful error. Cool. Another cool library that we're going to use a decent bit is called matplotlib. Matplotlib is sort of the grandfather sort of graphing and charting library in Python. So we can say import matplotlib.pyplot as plt, and we can run and we can graph something. So a simple thing that you can do to graph is you can just get two lists of things, and you can do a sort of a line plot. So if you do plt.plot, we can see, boom, there is our graph of our parabola there. Very fun. Is Conda installed in Kaggle? You know, I don't actually know. I do think that it would be difficult to use Conda in Kaggle. But I mean, we could try. Let's see. Pip, or no, not pip. Which Conda? Ah, Conda is installed. Interesting. I love whenever in this stream I learn something new. Conda is installed. Can we Conda install NumPy? Maybe. But we can look at more fun uses of matplotlib as well. Great question. It will only install these packages in the Kaggle environment. And in fact, okay, we can kill this. Maybe I just wouldn't recommend using Conda in Kaggle. But so the answer here is that they'll live in Kaggle. There is a weird thing that if you already have imported a library and then you install a new version, you cannot re-import that. So you will have to actually, if you installed something and it was the wrong version, you will actually have to stop your kernel, and before you ever try to import it, install the updated version and then import it. This is sort of like a weird edge case that I've run into before. But yeah, Kaggle is like Google Colab. They're both based on Jupyter notebooks, and I find them both very nice. Okay, so now for the big library that we'll be using and that will actually lead us into making our first submission is pandas. So pandas is a data analysis library that essentially gives you an Excel spreadsheet, or excuse me, a Google Sheets sheet in Python. So one way that we can create some data is come up with a dictionary where each key is the name of a column, and then each value is all of the data inside that column. And this might be a little bit weird to visualize, but once we create a data frame with it, so we can say pd.dataframe and pass in our raw data, and this will create a data frame that we will be able to look at, and it should be pretty. Okay, boom. So there is our little spreadsheet, or essentially a spreadsheet. You can see our first column is called state, and it's right there. And then all of our values are here: California, Texas, Florida, New York, Pennsylvania, and so on. And that is true for all the other key value pairs in our dictionary becoming columns in our spreadsheet. Does this vibe? Does this make sense to folks? There are a lot of reasons that we want to do this, but we'll kind of get to them in a second. Basically, turning something into a data frame makes a lot of different kinds of analysis very fast. Cool. So head is a helpful function that will just show you the first few rows of a data frame. So df.head, you just get the first couple. Kaggle does a lot of like rendering things nicely for you. So if you do this in a shell, you will get a sort of a trimmed down version of this, but Kaggle sort of nicely makes it kind of interactive. And then of course you can just render the whole thing, and you'll see more of it. We can pull out a single column, basically in the same way we would do with a dictionary. So you can treat your data frame almost like a dictionary of columns. And so you can see this is the number of Starbucks in each state, which is kind of neat. We can also get interesting stats for that column. So we can get the average number of Starbucks in states. We can get the standard deviation of Starbucks in states. We can get the minimum number of Starbucks and the maximum number of Starbucks. Let's see. What if our data is not consistent? Like if any one list we have more items than the other? Yes. So the answer here is that basically that's not a case where you should use a data frame. So data frames are inherently relational, meaning they show relationships between two things. So for example, this is like one row where it's California and CA and the population and the number of Starbucks. Now, there is a case where maybe we just don't know some of the numbers, in which case you could put none instead of leaving it off entirely. So, for example, what if we added Vermont? Vermont is VT, I believe. And then let's say we don't know the population of Vermont, so we can just say none. And then we can say 8 Starbucks because Chemery very conveniently dropped that new data for us. So here, we don't have a number for population, but we still need that list to be the same length so it knows that it's put in there. And then it gets rendered as, hey, there's sort of like a blank value here. But great question. Yeah, so inherently pandas data frames are only for things that are that you have sort of whole rows for every item. That will skew the population equals. Okay. We can add the now we can round it out by saying 650,000. Boom. Oh no, this is good. This would be a good example to show. We can filter out outliers. That will be fun. Okay, so now that should be the same. This should include one more Vermont. Our list of Starbucks. Very cool. Yeah. So now our summary statistics will change quite a bit. So now our average is 760, our standard deviation is 824, our min is now 8, that's Vermont, and I think our max is still California at 2,821. We also have a list of columns that we can make use of. So df.columns gives you all of the columns, and you can, of course, index into it. So if I say, what is the third column, I'll get number of Starbucks. Each individual column also kind of works like a list, so we can use it in a loop. So we can say, iterate over our list of states, and then print them out. So we get this. California is a state in the US, Texas is a state in the US, so on and so forth. We can also use them in graphs. So this is a super convenient, Pandas makes this super convenient to just put in your 2 columns and then to graph them up. So we have number of Starbucks in state versus population. And so plot here gives us, interestingly, it gives us some noise because we're treating this like a line graph. But maybe a better visualization for this would be not a line graph, but a scatter plot. So we can say scatter. And so now we just get the individual dots here. And so I guess down here we have, well, I guess that's got to be Vermont. Oh, I guess Vermont does have a small population. Yeah. Well, and so you see we have this, I mean, I would call that like kind of a super linear, kind of a quadrilateral, not quadrilateral, a quadratic parabola there, which is kind of cool. You can also filter your data frame. So for example, what if we just wanted to look at things that have greater than 2 million population? We can say population greater than 2 million. And what we get is not just the list of states that is greater than 2 million. We get actually a list of Booleans, or a sequence or series of Booleans. And what we can then go and do is we can use this sequence of Booleans to filter our data frame. So if we pass this population greater than 2 million, if we use that as an index, then we will get a resulting data frame just of the rows in our data frame that are bigger than 2 million. Yeah, it could also be an exponential curve. Lots of different curves we can fit to that. We can also create new columns, and like one super nice way to create new columns is by doing arithmetic between existing columns. So I can say the population divided by the number of Starbucks is the number of people per each Starbucks. So here we can see there are 14,000 people for every Starbucks in California, whereas there are 28,000 people per every Starbucks in Texas. And then all the way down here, there are 81,000 people for each Starbucks in Vermont. Vermont really is a Starbucks desert. Like, it's a small state, but it's got even fewer Starbucks. So what if we just wanted to analyze states that have a Starbucks for every 30,000 people or fewer? So these are the Starbucks wealthy states, right? These are the states that have a lot of Starbucks. So we could get our list of states, so states with a lot of Starbucks, and then we could add a column that says caffeinated equals highly. And you will, no cortados except for in local cafes. I love a cortado. I made 4 cortados today. I did not drink them all. I gave them to friends. And this will cause some issues. So why is Python complaining about this? Well, because data frames are meant to deal with such large quantities of data, we want to be careful about when we copy things willy-nilly. And so here, we did not actually create a copy of our data frame with these with this condition. We actually created a view into our data frame, or you could also call it a slice from a data frame. And so here, a value is trying to be set on a copy of a slice. And there are different ways that you can deal with this, but one simple rule of thumb is if you want to make a copy of your data frame, do that explicitly with .copy. So we can see this does look right. But if we wanted to get a new copy of our data to deal with sort of like as we choose, then we can say .copy right here, and this gets rid of that error. So just know that Pandas will not just copy data for you for free. It will try to be efficient. But if you want to create a copy, then say .copy. Cool. Not using Markdown. Just make a submission to the competition. So all we need to do to submit to this competition, remember our competition is to look at a CryptoKitty and then predict how much people are asking for it. All we need to do is to submit a file called submission.csv in the right format with all of our predictions. Luckily, we have provided a sample submission.csv that's already in the right format, and so we can just use that one. So if we do, another way of getting data into Pandas is to do read CSV. So if you come over here, I'll temporarily move my face just to show you this. This button down here, if you click this, it opens up your little side pane here. And now I will go back down to my corner. And you can click in our input right here, and this is all of the input data for the competition. Oh yes, I had trouble with this last time. Can you walk us through a little more slowly? Absolutely. Thank you for flagging that. And please guide me and give me feedback on specifically what we can dig into more. So, I guess big picture, to participate in the competition, you write a notebook, and that notebook needs to create a file called submission.csv. And so there are lots of different ways that you can create a file in Python, but the one that we'll be using is from a pandas data frame, creating a CSV file based on our data frame. So sort of step one is to get a data frame in sort of the right format. And one way is to use over here in our file system, our sample submission.csv. So if we start, let's not deal with this right now. If we just say pd.readcsv, and then in here, this stuff, I just came over here and clicked copy, and then pasted that in between the quotes. So that's our sample submission. And if I read that in, let's look at the format. So we have one column called ID and one column called price. And you can actually see if you, let's see, go to competition. If you click over here on overview, you can see submission file, and we want it to say ID and price. That's all we want. So here, these are all of our IDs for our individual CryptoKitties that we're going to be predicting on. And our sample submission just says all of them are 0. Like we're just saying all of the CryptoKitties are free. And so this will probably be a pretty bad prediction, but we're going to try it anyway. So now that we have our sample submission df, we can turn around and use .toCSV. So we want our file to be called submission.csv, and we want to pass this parameter called index equals false. So if you notice, pandas by default creates an index for us, and it will try to write that to the file unless we tell it, no, I don't want you to do that. So all we need is our ID and our price columns. And so by passing index equals false, that sort of fixes that problem for us. So now we run this, and you should be able to see submission.csv here. I think you should be able to open it. Let's see. I guess you can download it. So if you download it and open it, we should see something in the right format. And we, in fact, have it in the right format. Look at that. We have our ID and our price. And so now that we have gotten to this point where we are generating a submission.csv, now we can come over here and click submit. And when you click submit, it is actually going to run all of your code again. So we can click submit. And now over here on the left-hand side, it will try running all of the code fresh. And if we have any errors, it might actually stop our file from submitting. Yeah, I will drop I'll drop the overview. Here is the main Kaggle competition. And then here is my notebook that I'm working on right now. And it's taken a second to run. And you can actually see the previous time I submitted this. So I tested this out. And so you can actually see how we are likely to do. But we'll wait for it. So it's running all of the code in our notebook. And we obviously have a lot of code in our notebook that is not related to the competition. So if you were doing this for real, you'd want to remove all the code that you don't actually need to make a submit as fast as possible. Oh, also, random reminder, if you are filling out the form, these are all of the colors that we can do. I am colorblind, so I don't actually know what the complete list is. But you are welcome to pick any of these colors, and you are welcome to say combos. So if you want to do, blue and red or something like that, then you are welcome to do that. So we can click through just to see how things are going. And you can see our logs. So this is kind of fun. You can see all of our logs from our stream down here. Oh no, error report. Oh, this is when we tried to install Conda. Ha 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 ha. Nice. It's still going. And boom. Okay, we got a score. And so at this point, if anyone else has done this, I'm the host, and so it's a little bit different for me. But if anybody else has done this, we should be able to go to our leaderboard. And Shoria has submitted and got the score 38.98. And that is what I got as well. Now, a fun fact that I will share is that there is a public leaderboard and a private leaderboard. And so your results are both evaluated publicly, and then there's a separate part of them that's evaluated privately. And you don't know what part is evaluated publicly or privately. So it's half of your predictions are graded publicly, and the other half are graded privately. And I, as the host, can see up here that there were that the private score is actually better, right? So this is the average amount of error that we have per prediction. So 38 ETH or 38 Ethereum USD is let's see, $61,000. So on average, we are mispredicting by $61,000. That is, I guess, a good thing to know. And that's quite a bit of difference. And so ideally, we would get better than this at some point. But it's a good baseline. If we just literally guessed 0 all the time, that's what we would see. And so congrats. If you have just gotten to this point and pressed submit, you have successfully submitted. And you are, if you are a contributor, you are in the running for the raffle. Which actually a thing that maybe we'll take a break now and talk about is how do you become a Kaggle contributor? So the goal here is I just don't want people trying to spam the raffle by making 17 accounts. And so in order to be considered for the raffle, you both have to submit, which Shoria 7 did incredibly well. Well done. But you also need to be what's called a Kaggle contributor. And so this is, to be clear, this does not require like having a credit card or anything. It just requires doing a few simple steps on the Kaggle platform to kind of prove that you're a real account. So you see right now, also, Shoria, thank you so much for doing this because this is a great example for me to use, and I really appreciate you. So you are a Kaggle novice, and you can see that your little progress bar here is low. But if you click through to the Kaggle progression system, boom. Oh no, Shemarie can't submit this time either. Okay, we'll spend a few minutes debugging with you then after we talk about progression. So Kaggle divides folks up into a few categories. Novice, where all you have to do is register, and then contributor, where you only have to do 4 things. One is run a notebook or script. So if you have done this live stream along with me, that's check. Make 1 competition submission. If you just did what I did, then you've made a competition submission. So Shoria 7, you have done this. And then 2 more things. Make 1 comment and give 1 upvote. Now, if you're like shy and you're like, I don't want to comment or upvote, then the easy thing for you to do is just go over to our competition, go to discussion. You can either say, oh, incredible, we got a comment. You can either come and create a new topic and introduce yourself, or you can just come over to mine and say, Maria Prata left me a comment. That's fun. But you can just come and leave a comment and say, hello, Will. Happy Global Hack Week. And so then you will become a Kaggle contributor. Your image will look a little bit nicer, and you will be in the running for the raffle. So I will come over to the leaderboard, and I'll just look for folks that are contributors when I'm doing the raffle. This should not be a barrier to anyone. The only thing that it does is sort of verify that you're a real person and your Kaggle account is like not a bot. And so that is the reason that we're doing that. But if you have any issue becoming a contributor, let me know. There shouldn't be any, the 4 things you have to do are really quite simple. It's just run a notebook, which you should have already done. Make 1 competition submission, which you literally have to do to be considered for it. Make 1 comment, which, hey, feel free just to say hello on my topic, and then give 1 upvote. Upvote me or a friend or anything. And so that should be pretty straightforward. So let's see. Shemarie, you said you were having trouble submitting. If you are willing to give me a tell me what you're seeing, I am more than happy to help dig in with you. Otherwise, you could keep it going. So we're back at Python Crash Course. We made a submission. So yeah, I mean, I guess a couple of general debugging like recommendations. One is have as little code in your notebook as possible to still get your submission. So don't, sometimes I'll have one just sort of like playing around notebook and then another notebook that's like my official submission notebook. So if you want to try weird things like, oh, can I do this? Do that in your playing around notebook, and then only have the code that's like, this is the official stuff in your original one. So it's less likely to have errors. Other things that can happen, if you have an error somehow above here, that can cause issues. If you don't have index equals false, then you will have you'll have issues there as well, because that will add that extra column of IDs. And then the big thing is you just need to make sure that there's a file called submission.csv right here. But any other concerns or issues, I am happy to debug now. Otherwise, we can do a quick round of my favorite things. This is something that I've tacked on, especially for when folks stick with it who do know Python. It's fun to throw some other stuff out there. Although we were kind of going deeper this session anyway. We looked at hashing and hash maps and scoping a little bit. So I think we actually already covered exponents. But fun fact, if you make a number less than 1 as your exponent, you can get square roots for free as well. So 8 to the power of 2 is 81. 9 to the power of 2 is 81. But 9 to the power of 1/2 is 3. Isn't that fun? List comprehensions are another favorite of mine. So if you have a list of numbers, this is something that happens a lot of times, is that you have a list of numbers and you want to create another list of numbers. So you want to do some kind of transformation to those numbers, right? So the old dumb way would be to say, well, I'll create a new list called numbers squared, and then I'll iterate through all of my numbers, and I will raise each of them to the power of 2, and then I will append them to my new list, right? And that does work. There's no actual problem with that, except in Python, you can be very cool and use what's called a list comprehension. So it is a way of comprehending your previous list in a new way. And the way that you write this is you basically condense your whole for loop into a single line between square brackets. So we can say number squared for number in numbers. So this is basically your for loop part right there. And this is the code you're running for each element. And you put that in square brackets and you get the whole list. And you get to do that in 1 line instead of doing that in 3 lines. There are certainly limitations to list comprehensions. If you're doing something that is actually kind of complicated, then I would recommend using an actual for loop. But if you're just doing a quick, I want to reduce all these numbers by half. Okay, thank you for the error report. Attribute error, sample submission df to CSV. Trace that. Let's see. Sample submission df to CSV. Sample submission and name not in. Interesting. So, that is interesting. So one potential concern is because we messed around with installing things in Conda, that has done something strange. Interesting. So here's what I will say, Shemari. If you want to try, and actually we can all do this together, because really the only part that we need to really submit is just this right here, right? These 2 lines of code actually make a whole submission for us. So maybe we can walk through this, and this will help us narrow things down. So if you come over to code, you can always create your own notebook by clicking new notebook here. And we'll call this part 1.5, just submitting. If we just paste these lines of code, and we can actually delete this cell by right-clicking on it, this by itself should be enough You created your own notebook 3. Oh, okay. So if you've been using sort of the same notebook to follow along, first of all, love that. That's so fun. Also, try creating a new one here and just seeing if you paste this. If you paste this and run it. Oh, yeah. Okay. Apologies. We have to import pandas. So if you just paste this snippet of code into a new notebook, and then you come down to submit to competition, this should work for you. If not, we can continue to debug. If anybody else has issues with submitting, now is like a great time to just dig into it, because I mean we have, in theory 30 more minutes, which we'll probably wrap up a little bit early. Yeah, but yeah, we have not that much more to cover today. Another of my favorite things is chaining comparisons. So we compared one thing at a time. So if 16 is less than my age and my age is less than 21, this is a way of saying you can drink but you can't drive. But we actually don't even need this and. In a lot of programming languages, you need one comparison and then you need to and that with another comparison. But in Python, we can just say, in the very mathy way, 16 less than my age, less than 21. And if we run that, both of these work. And if you see someone who is, this is, I think, actually recent-ish. I want to say maybe 3.8, Python 3.8 introduced this. I could be wrong. But chaining comparisons, very fun. Another great one is negative indexing. So say we have a list of ordinals, first, second, third, fourth, fifth, and I don't want to say the second or the third. I really want to say the last index. Well, one way you could say this is take the list or the length of your list and subtract 1 from it, and that gives you the last index, and you can get the last thing, fifth. But in Python, we can be very clever, and we can say if I pass a negative number to our ordinals, then that will by default give me the last thing in the list. And if I pass a number sort of lower than -1, it will actually give me that number from the end. So -1 says 1 from the end is fifth, -2 is 2 from the end, and that is fourth, and so on and so forth. So that is kind of a fun way to, if you just want to know what's at the end of a list, that is a fun way to get the last thing in the list. I think last time somebody asked about some interesting ways of graphing things, and so we walked through. I think we already imported NumPy, but we can import again. You can, with NumPy, generate random distributions of numbers that are more complex. So here we can get a normal distribution from NumPy, and we can say size is 100. So this will give us 100 x values from a normal distribution. A normal distribution, if you're not familiar, it looks like this. So most of your data is in the middle, and then some of your data is a little bit further out, and then very little data is at the edges. So it kind of gives you a nice sort of sort of sloping pattern. And in fact, one way we could do this is, so we have two random lists. I mean, I guess first of all, we can just look to see what's inside them. So inside X, we have an array of a bunch of relatively small numbers. And we can do plt.hist to get a histogram. And you will see that, in fact, okay, we only have 100 numbers, so it's not perfectly smooth. But you get basically frequency counts showing you how often numbers appear. And I mean, we could crank it up to 1,000 to probably get a slightly better looking, there you go. And we could crank it up to 10,000. And it looks even a little bit better. You can also, into histogram, you can pass the number of individual bins. So here, this is broken up into 10 different bins: bin 1, bin 2, bin 3, bin 4, bin 5, bin 6, bin 7, bin 8, bin 9, bin 10. But you can say, bins. You could say, give me 100 bins. And so you get a little bit more granular detail in your histogram if you pass bins. But let's bring this down back to 100. Oh, Darwin has come up to say hello. Would you like to see Darwin, y'all? Hey, bud. Yeah, do you want to come and say hello to the internet? Say hello, Darwin. This is the baby. Oh yeah, you're okay. Nice. They love you, Darwin. They love you. Where were we? Oh yeah, histograms. So you can see if you use a really high bin size and you don't have that much data, your histogram kind of is useless. I would say useless. Like you still kind of, if you squint, you can kind of see the shape. But if you don't have that many data points, using a smaller bin size of maybe 10 gives you a little bit better looking data. This is kind of interesting. This like looks like it's not a normal distribution. Like I assure you, it was sampled from normal distribution, but this looks skewed and strange and stuff, you know. But we can also generate sort of more interesting normal distributions. So this has an average. So location is like your average middle point. And so we could say an average of 2. And then scale is your variation or your variance. And so 1.5 will spread it out a little bit more. And so this gives us 2 different distributions. If we just did the histogram on this as well, we would see a little bit different. So here you can see we basically, our middle point is around 0. But here our middle point is basically around 2 right there. Right on. So we can also just plot these, which is kind of cool. You can see, oh wait. Oh, no, these are histograms, both of them, which you can see is, is similar. And then if we want to, we can visualize 2 different 2-dimensional distributions like this. So we're first doing a scatter plot of x and y, and then we're doing a scatter plot of x prime and y prime in the color red. And then we're giving it a label. And we can pick some random labels just to show you the X and the Y labeling. And so there you go. There's like a cool little graph of the reds and the blues, say. Let's see. How much would you pay for submission file not found? Okay, so just to verify, you created a fresh notebook and you just pasted in this code and you just hit submit. Oh, never mind, it worked. Okay, incredible. That's so good to hear. So my guess is that you are doing something else in your old notebook that is maybe installing a different version of something. I both love hanging on to a notebook, but also sometimes it can be good just to start fresh, just because it's, if you have one cell that did something weird, then it can throw off the submission process. But I'm glad that worked out. Another thing to note is that you get 10 daily submissions. I tried to set that at a number that is like basically as many as possible, or like basically like you should never be limited by that. And if you're like, yeah, Will, I've been working and I literally came up with 10 different solutions and now I want to come up with an 11th, let me know and I'm happy to increase that. But I think 10, usually no one has any issue with that. That usually is enough. In fact, I will make this public. Boom. Cool. I think that's about what we have for today. I think that's our show, folks. I will drop the check-in link again. You are very welcome, Chemery. If you did not fill out our form, this is the feedback form, both to let me know how things are going, and then also to vote for what color glitter I put on my face on Friday. And we should be able to come in and see. I won't show individual responses, but I think we can see. Oh, no, don't look at those emails. We can see. Okay, for some folks, it was just about right. Or for a lot of folks, it was just about right. For some folks, it was kind of a little bit fast. But glad to hear most people had a good time. Yeah, maybe. I mean, as long as you're using a fresh notebook when you try to submit, I would imagine it should be okay. It is also possible that you're getting an old version of something. Yeah, maybe try deleting the old notebook. But as long as that new one is working, that gives me some hope. And if you continue to have issues with this, I'm happy to debug more. Okay, cool. We have, I guess, blue and silver are the top 2 leading contenders. And then green and red follow the pack, and then purple and purple again. Okay, so technically purple is solid there as well. They just added some context. Cool. Right on. In that case, maybe we can check in on discussion. Oh, we got some more. Oh, I love that folks are getting in here. Yes, and I'm so proud of all of you for engaging. All right. Pink and iridescent. Oh yeah, there totally is pink. It looks like there's some darker colors as well. So if you want to add those in, feel free. Cool. Maybe next time we'll open it up to new suggestions as well, and we'll just update keep the options updated. Okay, do we have any additional questions? I think this was an incredible stream. I liked that there was enough Python experience that we got to like be a little bit nerdier and go a little bit further, a little bit faster. So that's always really cool. The questions were great, y'all. I'm really looking forward to. So I guess I'll lay out the rest of the week. Tomorrow we'll do. I love doing just a very simple model to get things going. So tomorrow we'll do some linear regression, just with our one numerical data column. Then we'll also get into pre-processing our data and like look at pushing around pixels and like see how images are represented. Then Wednesday, I'm doing 5 streams, which is honestly, it's a lot of streams. Wednesday, we'll start getting into TensorFlow and Keras and using that to generate predictions. Thursday, I think we'll look at ensemble models, so looking at stitching multiple models together. And then Friday, we'll do AI explainability. So like trying to figure out why is our model doing what it's doing. And hopefully that'll be enough content to keep folks interested. But that is the rest of the week. Great questions. Oh yeah, incredibly nerdy, incredibly fast was our tagline last time, which I think we need on a t-shirt. But yeah, thank you for being here. Any prerequisites? Not really. I will say, here's the way I'll put it, is today was functionally beginner friendly. That if you aren't into ML, like today should have been okay. Tomorrow will also be beginner friendly. Wednesday will be kind of moderate. And then Thursday and Friday will probably get a little bit more advanced. I mean, as always, everybody is welcome to all sessions. And if you have questions, I will always be there to answer them. So it's not like, hey, if you don't understand X, Y, or Z, get lost. But if you want to look into anything, looking at the package scikit-learn is what we'll be using tomorrow. And so that can be maybe an interesting thing to play around with. On that note, unless there are any other questions, I think we will call it a stream and wrap up. But again, thank you so much for being here. I will play you out on ukulele, but it has been not ukulele, on kalimba. It has been an absolute blast having everybody tune in, and I will see you all tomorrow. All right, thank you all so much for being here. I will see you tomorrow, an hour later than yesterday or than today. But pull through and good luck on the competition.